Hello, hello. Hope you're having a great day, and I hope you're looking forward to another fantastic evening with me for some Algebra 1. Today we're going to be talking about how to convert a linear equation from one form to another. We're going to be going from standard form to slope-intercept form, or from slope-intercept form to standard form. And you can actually interchange these back and forth. And we're going to talk about how to do that today, and we're going to practice some of that. Now, this part at the top of your packet should be done in class. So I'm leaving it blank on the video on purpose, just in case anybody's watching this before they come to class. I don't want to ruin the surprise, but we'll be doing this part in class. Today, let's just talk about the mechanics of what it is that we're doing. The first thing that we're going to look at is how to convert from standard form to slope-intercept form. Because sometimes standard form is easier to graph. You can find the intercepts and connect them. Sometimes slope-intercept is easier to graph because you can find your y-intercept and you can use your rise over run. It just depends on the equation. If it's working one way, great. But if it's not working, you want to be able to change it to the other. So let's take a look. For converting from standard form to slope-intercept form, really the only difference, and just a quick review, standard form is ax plus by equals c, and slope-intercept form is y equals mx plus b. So let's focus on what we want it to look like. We want it to look like this when we are done. We want it to be in slope-intercept form, which is y equals mx plus b, when we're all finished. Now, the thing that stands out to me the most is that y is over here all by itself. Everything else has moved to the other side. So the only thing we really have to remember, if we have an equation in standard form, we don't want it in standard form, we want it in slope-intercept form, we need to isolate y. It's that quick, that easy. Once you get y all by itself, everything else will magically work itself out. Let me show you what I mean. Take this example. The first thing we're going to do is we're going to make a note of where our equal sign is, okay? Because when we're talking about isolating y or x and y on the same side, we're talking about of the equal sign. This is like our dividing line, our little fence, okay? That's what separates the variables and the things that we're working with. So I know I want y all alone, so I'm just going to highlight it in pink. I'm going to highlight my x as well. My x, I'm going to highlight in yellow. And you can use different colors as long as you're using two, one for x and one for y. So right now, x and y are both on the left side of my equation, and I want to move x to the other side so that y can be all alone. So I'm going to take this entire term, 9x, and I'm going to move it. It's a positive 9x, so I'm going to do negative 9x, and that way it will cancel. But of course, if I do it over here, I've got to do it over here. Now, on the left, it will cancel. That's fantastic. That leaves me with just negative y and then my equal sign. Over here on the right, 1 and negative 9x, I can't combine those together because this term has an x and this term doesn't. Again, this term has an x and this one doesn't. So I can't actually put them together. So I'm just going to write them out. I would do, if I could, I would do negative 9x minus 1, but I can't actually do it because one has an x and one doesn't. So I write them separate, that's fine. There's my x, here's my y. I'm getting closer. Now at least they're on separate sides, but y is not alone yet because it has this negative attached to it. Remember, this is actually a negative 1. So if I divide both sides by negative 1, I can get rid of it. Over here, go ahead and divide each term by negative 1. So you're basically doing the same thing to all three terms in this equation. Here, my negative 1s will cancel, and I'm left with y all alone. That's what I wanted. Still got my equal sign. Negative divided by negative is a positive, and 9 divided by 1 is just 9. And of course, my x comes with it. Negative divided by negative is a positive, and 1 divided by 1 is just 1. Dividing by that negative, the only thing it's going to do, if it's a negative 1, is change the sign. So just think through your signs and your division, and you should be good to go. You're left with y equals 9x plus 1. Y is all alone, so I know I'm done. That means that this 9 is m. That's my slope value. Remember that? M, that's 9. My plus b in this equation is plus 1. So if I wanted to, I could graph it using that equation. Let's take a look at another one. How about this one? Here we've got 2x plus 3y equals negative 15. My job right now, x and y are on the same side of this equal sign. I'm all tongue-tied today. X and y are both on the left. I don't want that. I want y all alone. I want y equals. So we're going to start moving things. First things first, I'm going to move this whole 2x term over to the other side. It's a positive 2x, so I'm going to do the opposite with a negative 2x. When I do that, it will cancel on the left. Good for me. Bringing me down with just 3y. Still equals. Now, negative 15 and negative 2x, I can't combine them. One has an x and one doesn't. So I'll write it out as one long equation, and that's fine. Negative 2x first, and then negative 15 at the end. And I'm always going to put that x term first, just because that's kind of like the way you use capital letters and punctuation when you're writing in English. When you're writing equations in math, the x is just usually first. Now to get y all alone, I'm going to have to divide by 3. So no problem on the left. On the right, though, I'm going to divide by 3 for both of these. Not just the first term, not just the last term. Everything gets divided by 3. So on the left, they cancel, leaving me with y all alone. That's what I wanted. Yay! So let's see what the rest of our equation is going to be. I've got negative 2 divided by 3. I can't actually do that division. It would give me a decimal. So I'll just leave it as a fraction. Negative 2 divided by 3 times x. And then negative divided by a positive is a negative. And 15 divided by 3 is 5. So my equation is y equals negative 2/3 x minus 5, which works out great. That means negative 2/3 is my slope with a rise of negative 2 and a run of 3, and negative 5 is my y-intercept. So I could easily graph this using this equation. Why don't you pause the video, take a look at number 45, see if you can tackle that one. Come on back when you think you've got it. All right, so let's look at this one together now that you had a chance to try it on your own. I know that right now, x and y are on the same side, but I want y all alone. So I'm going to move this 5x term. I'm going to get it out of the way because I know it shouldn't be on the same side as the y. Not for slope-intercept form. On the left, these two will cancel, leaving me with just negative 6y equals, now, negative 36 and negative 5x. One has an x and one doesn't. So you can't actually subtract those. So you have to write it out as an equation. Next, we're going to divide to get y all alone. Divide by negative 6. Here, it'll cancel. Then here, divide by negative 6, divide by negative 6, because we're going to take it one term at a time. So on the left, it canceled, leaving us with y. Negative divided by a negative is a positive, so I don't have to write my sign symbol here. And then 5 divided by 6. Well, I can't do 5 divided by 6. I would get a decimal. So just leave it as a fraction. Remember, slope is rise over run anyway, so that works out for us. A negative divided by a negative is a positive, and 36 divided by 6 is 6. So here is my final equation, and it has a slope of 5 over 6 and a y-intercept of positive 6. So you've converted from standard form to slope-intercept form. Why don't you try one more? Try number 46 on your own, and come on back when you think you've got it. How did it go? Were you able to get y equals 3 over 2x plus 3? I know some of you are going to have a really hard time with this fraction because you're going to say, well, 2 can go into 3. It goes in one time, and there's 1 left over, so it should be 1 1/2, right, Miss Chiefy? Remember, for slope, it's better if we just leave it as an improper fraction. So leaving it as 3 over 2 is just fine. It's actually simpler in terms of what this whole equation looks like. Hopefully, you're beginning to understand how to go from standard form to slope-intercept form. In part 2, we're going to look at how to go the other way, from slope-intercept to standard. So come on back.